Hello everyone. Last time we looked at what's an infinite limit and we also talked about vertical asymptotes. In today's lecture, I'm going to be talking about infinite limits. Properties of infinite limits, okay? So let's talk about what is the properties we're looking at. So here, if C and L are two real numbers and we have two functions f and g, such that the limit of the function f as x approaches c is infinity. Now remember, infinity means that the function is unbounded, and positive infinity basically means the value is increasing without bounds. Please remember that this infinity is not a real number. Rather, it tells us that the function is increasing without bounds. Let me write it down. The function is increasing without bounds. Okay, and the limit of the function gx as x approaches c is L, and this is a real number. Okay, let's look at the sum and difference. It says if you're taking the sum or difference of two functions f and g, and you're looking at as x approaches c, then the limit of the sum or difference is function, which is increasing without bounds, and in the short form we say infinity. The product of these two functions as x approaches c is positive infinity when the real number is positive, and negative infinity when the real number L is negative. Now if you have a quotient of these two functions with g in the numerator and f in the denominator, and the limit as x approaches c. Now remember, if a function is in the denominator and it becomes large, very large, then the original function g over f will become very small. It will approach 0. So these similar properties also will hold for one-sided limits and for functions for which the and for which the limit of this function fx as x approaches c is negative infinity. Let's look at an examples. Now, the limit of the function fx as x approaches c is infinity, where the gx is approaching negative 2. So the limit of this function fx and gx. Now remember, this, even if to a very large number you add a -2, it is still going to be a large number. So the answer here is positive infinity. Now, if you're taking the product of these two functions, so basically applying the properties, guys, here. Okay. Now, if I'm taking the product of these two functions and the positive infinity when multiplied to a negative number, remember here, we're going to get the limit would be, so in this scenario, positive multiplied to a negative number is negative infinity. And over here, the limit, so as g is a negative number divided by a very big number, this whole limit will approach 0. Now, let's look at another set of examples. We would like to calculate the following limits, and we would now remember, because you're going to have some unboundedness. So when you do these limits, you have to make sure that you're doing the one-sided limits, and in examining these we will be using a sign analysis. Now that's going to make our life very simple, guys. Otherwise it's going to be very tedious to find the limit. So I'm going to use a sign analysis. I'm going to show you what it means. So the limit, now x approaches 0, 5 minus x over x squared. If you draw the graph, you will see that there is going to be a vertical asymptote at y-axis, because x approaches 0, there's a 0, it's a 5 over 0. So vertical asymptote, notice there is a vertical asymptote at x equals 0. Now, so the limit of the function as x approaches 0, we're going to start with, say, the right-hand limit. So the limit as x approaches 0 positive of 5 minus x over x squared. Now, this is our function. So what we normally do is when I'm looking at this one, so I'm going to look at the sign analysis. So my original function, so in order to fit, so what I say, let my x be, say, 0.1. So what is my f of 0.1? So it's 5 minus 0.1 is 4.9, okay, over 0.1 square, right? What is it? So top, so you can eyeball it. Okay, sorry. So it's 5 minus 0.1 over 0.1. So the sign analysis is basically saying that you look at the sign on the numerator and sign in the denominator. Now, anything which is in the denominator is always going to be positive, right? So this one is going to be a positive number, which is 4.9. And anything when you square it up, it's still going to be positive. So what does that mean? So when you're taking values which are very close to 0 coming from the right-hand side, the sign analysis says the function value is a positive value. Now that means the limit for this would be positive infinity. That's the meaning of it. Okay, now let's look at from x approaches the left-hand limit. Now that means the limit as x approaches 0 minus of this function fx. Now in order to do that, so I'm going to say let my number be very, very close to 0, but it's going to be a negative, so I'm going to say x be, in this scenario, say minus 0.9, very close. So what is the function value of negative 0.9? Now 5 minus with the minus number is going to be positive. So we can just do it in our heads. We don't really literally have to write it down. The first time I wrote it for you to see, but if you still want to do it, you're welcome. Minus of minus 0.9 over, now remember, anything you put value in the denominator and square it, it's still going to be positive. So what happens here, guys? It's a positive over positive numbers, right? So this limit is going to become again positive infinity. So this answer is positive infinity. Notice this function, if I'm coming from the left-hand side or the right-hand side, it is going to positive infinity. So the answer is positive infinity, because both sides, left or right, it is a positive infinity. Okay, I'm also going to show you on a graphing calculator that how the graph looks like. So as I said earlier, we're going to talk about how to show the graphing calculator. What I've done is I have used a web page which is freely available for everyone called desmos.com. So I'm going to show it to you guys over here. So desmos.com and a graphing calculator. I'm going to use that, and you can also use it if you want to check your answers. So what I did was I literally wrote it down over here, the function, and I can show it to you again how to write it down. So what you normally do is because it's a 5 minus x divided by x, and you can say you can use your keyboard to do it. It will help you with that. So I'm using my keyboard to do everything. So 5 minus x over x squared, and as you're doing it, you will notice this is how the graph looks like. And there are some buttons over here on the side. You can zoom in and zoom out. So if I do zoom out, you can see the bigger picture. This line is basically the asymptote. Now you don't get to see it, the vertical, those dotted lines, but clearly from the graph it is clear that your function as is growing, coming towards 0 from the x value is coming towards 0 from the right and the left, the function is increasing without bounds. So that's, as I said, once again, I'm using this web page freely available to you guys, desmos.com, calculator, plugged in, the function, and then automatically it gave me the graph. Okay, so coming back over here, so notice this was done by hand, and this is what we have done using our calculator, our graphing calculator. Now we're going to look at the next function. Limit of x approaches 3 of 1 minus x over x squared minus 3x. Now we would like to know, because remember it's a right-hand limit and a left-hand limit. In this scenario, if you notice, I could, I know when I plug in 3 in the denominator, I get a 0. Okay, and so I would like to know how the graph looks like. So I can quickly go to my graphing calculator, get this graph, and know the basic idea. And then we will also do it by sign analysis, because when I give you questions like this in the exam, I need to see the sign analysis. And you can check your answers. So here's another way. So here what I'm going to do is I'm going to add another set. So I'm going to click on this second. You could see the 2 was highlighted like 3. So when you click it here, I'm going to write down the function, which is given to be it's 1 minus x divided by x squared minus 3x. Okay, now notice what is it? These 2 are highlighted, so you will have the same graph on both of them, and we don't want that to happen. So what we normally do is we click on the first, and that way the graph is not showing for the first one, but the second one is executed, and that's what we want to see. So when you look at the graph, this is how the graph looks like. So there are 2 points where you see vertical asymptotes. One it at 0, the other is at 3. Okay. Now if I zoom out, it seems it is touching, but remember these are the points where it is 0. So if I zoom in, you will see it much more clearer. So 3 and 1. But we are being asked to find the limit at 3. Notice what's happening. Just looking from the graph at 3 here. As we are coming to 3 from the left-hand side, the function is increasing without bounds. And when you're coming to the function 3 from the right-hand side, the x value coming to 3 from the right-hand side, the function values are decreasing without bounds. So here the right-hand limit and the left-hand limits are going to go to opposite values, like positive and negative infinity. Okay. Now we're going to do it so we have got an idea looking at the graph, on the internet, and now using this graphing calculator called desmos.com. Once more, desmos.com, guys. Now I'm going to do it with the help of the analytical way. Okay, so let's come over here. Now remember, even though it has vertical asymptotes at 2 values, our job is to look only at 3. So what we do here is, so when I say, remember this is the function f of x, okay? And we're looking at limit as x approaches 3. Knowing from the graph that there is a vertical asymptote, we just need to show using sign analysis. So f of 3, if you plug it in, you have 1 minus 3, negative 2 over 0. That means you have a vertical asymptote at x equals 3. That's what it means. Okay, now let's look at the right-hand limit. What's the right-hand limit says? The right-hand limit says limit x approaches 3 positive of the function fx. Now we want to do the sign analysis. So I simply write my f. Now for 3 positive, in my head I'm doing this. Okay, x equals, say, 3.1. And the function is going to look like, on the positive, it is 1 minus 3.1. Automatically it is negative. Okay, and when you plug in values over here in the denominator, 3.1 squared minus 3 times 3.1. Okay, now that one means take out your calculators and see, do you get a positive number or a negative number? So quickly guys, take your calculators and see whether it's positive or negative. So you notice this is what we're getting here is a negative over a positive, because this is 9.61 minus 9.3. Okay, so basically it's a negative. And we also knew from looking at the graph, when you're coming from the right-hand side to 3, the function is decreasing without bounds. And also, our math shows it's negative infinity. Okay, so the right-hand limit is negative infinity. Let's look at the left-hand limit. Okay, so the limit as x approaches 3 minus of this function fx. Now, let's look at the sign analysis. Now, 3 positive, say x, 3 negative, so less than 3, say 2.9. So what is the f value? So 1 minus 2.9 again is a negative number. So 1 minus 2.9 is a negative number. And then we have 2.9 square minus 3 times 2.9. So what you will have equals 1 minus 2.9 is definitely a negative number. We don't have to write the values, we just know it's a negative number, over 2.9 square minus 3 times 2.9. What you notice is this also is a negative number, which makes it a positive number. So that means the sign analysis says the function is going to be a positive infinity. And clearly the right-hand limit is not the same as the left-hand limit. Remember, even the graph was showing us that. The values were basically either increasing without bounds or decreasing without bounds. Okay, let's do some more practice of sign analysis. And we're going to use some trig functions. Okay, for this one, this is a trig function, theta approaches pi halves. So what you're going to look at is the right-hand limit, which is basically limit of this function f of theta as theta approaches pi halves positive. So what is the sign analysis saying? What is my f? So 1 minus pi halves, so pi half positive. So what we basically need to know is what is pi half, and then you put 1 minus pi half. So go ahead guys, take your calculators out and once again do the math. Okay, so when you put 1 minus pi half, 1 minus pi half positive, so remember pi half guys is 1.5707. So for pi half positive, I'll say, hey, theta is say 1.6. So 1 minus 1.6 over cosine of 1.6. It's actually a negative over a negative. So basically the function is a positive. So the right-hand limit is a positive infinity. Let's look at the left-hand limit. So you're looking at limit as theta approaches pi half negative. That means you take a value less than 1.57 and you look at f of theta. You see when you take, say, let's say theta is 1.57, say 1.5. But you will have f is 1 minus 1.5 over cosine of 1.5. You will have a negative over a positive, you will have negative. So the answer is negative infinity. Okay. Now, that's how you use sign analysis to even apply it to trigonometric functions to find their limits. Let's look at one example, find the limits. Now I'm just looking at one-sided limits over here. Now here it says only 1 minus. Okay, so 1 minus means I'm just looking at, this is simply left-hand limit only. Now what we can do is 1 minus, again apply the sign analysis. Now remember this is my function f. So I say x is less than 1. So I can say, hey, xb says 0.9. So what is the function according to the sign analysis? The function at 0.9, top, no matter what happens, is negative. And no matter what you fill inside this squaring function, it's always going to be positive. Because you put 0.9 minus 1, again it's negative, but the square will make it positive. So the final is a negative. So the left-hand limit here is simply negative infinity. And we just did pi half, so let's look at this one. Here it's asking for pi half positive. And we already know that pi half is, as I said, 1.5707. So pi half positive, so I say let my x be over here to be, say, 1.6. So the function by the sign analysis is negative value over cosine of 1.6 we knew was a negative number. So the answer here is positive infinity. So it's positive, so the final answer is positive infinity. Okay. We're going to talk about sketching the graphs and then finding the limits, and if it exists, what do we do? Now here is a function. Now notice these two are actually squaring functions. It's a piecewise function, and both the functions inside this piecewise are squaring functions. Now we would like to know what is the limit of this function. Now if you remember, this is piecewise, and we did in our previous section 1.4 how to find the limits for these ones. So that means once again we will be looking at a left-hand limit and a right-hand limit. So let's look at the left-hand limit as s approaches -2 with a negative. So this function fs means all the values which are less than s. That means you're looking at this function on the top. Negative s squared minus 4s minus 2. Now what do we have to do? Just go ahead, plug in the values. So -2 minus. Now remember, once we have picked up the right piecewise function, we just go and do the normal limits. Then this negative is not going to work. It's this -2 which goes here. So it's negative of -2 squared minus 4 times -2 minus 2. Okay, this is what? -4 plus 8, -2. Answer is a 2. Let's look at the right-hand limit because you want to find the limit as s approaches -2. Now remember, for a limit to exist, the left-hand limit, very important to keep in mind, for the limit to exist, the left-hand limit should equal the right-hand limit. So in this one, the left-hand limit is giving 2. What about the right-hand limit? Let's look at that. Limit as s approaches -2 positive. Now positive means you pick up the right one. So you're looking at these functions, which is s squared plus 4s plus 6. Now after that, we just plug in -2. -2 squared plus 4 times -2 plus 6. So which is basically 4 minus 8 plus 6. Again, the final answer is a 2. So both the left-hand limit is the same as the right-hand limit. So our answer to this problem is a 2. Okay, guys. We have done a lot of practice of infinite limits. Now it's time for you to practice. So here are 2 slides for you to practice. These are the limit for find whether they have a vertical asymptote. Oh, no. So determine the limits, guys. I'm sorry. I'm sorry, this is not the right. I will make the changes in the notes when I post them online for you guys. So find the limits. Now these are one-sided limits, if you notice that. And then there's a question on the properties on infinite limits. Thank you, guys.